Alright, hello and welcome back. Let us finish up loops today. So this is where we got last time. We were lowercasing a string, going through every single little index inside of it, because we can go through 1, 0, 1, 2, and 3 all the way. We can iterate over every place by using some variable that keeps track of where we are. Okay, so let's do a little review. Let's, instead of counting up from 1 to 10, let's count down 10, 9, all the way to 1. So what will this involve? Well, again, we're going to need some variable to keep track of where we are, and it's customary to call that I, but it needs to start at 10 now. And then we need to keep on printing it out, and not incrementing 10, but decrementing 10 now, so that we can keep on printing downward until I gets to 1. I'll print that out. And then we should stop our loop if I ever gets any smaller than that. Alright, that's the idea. So let's do this with both a for loop and a while loop. Let's do the while loop part first. And then we'll do the for loop version. Alright, so let's call this, I don't know, countdown.cpp. And let's go into code from class, CSCI 41. And what do you know, it's lecture 7 today. So I'm going to make a folder called that. There it is. Go inside of it. Oh, we're not in CSCI 41, are we? Well, they're going to need that folder anyway. Let's go back. CSCI 40. Excuse me. We're going to make a lecture 7 directory there. And go into it. Okay, now that we're there, let's make that countdown.cpp file. So just a basic main function, and I've set up a key shortcut to write that for me. I'm very happy about that. So let's do a while loop to count down from 10 to 1. Okay, and this could be anything. You could replace these numbers with anything. And so we're going to start our I at 10. And while I is something, we're going to print out that value. And then we're going to decrement I. So you can say I equals I minus 1. You could say I minus equals 1. You could also say I minus minus. Okay? And also minus minus I is a thing as well, if you've read about that. So now it's just our job to figure out what we want I to be here. So we want I to always print, to execute this body, whenever it's between 10 and 1. So when does it stop? When do we want this loop to stop? Because this will guard against that. And I think as long as I is between 10 and 1, we should continue. And I is going to become smaller. So we want it to always be greater than or equal to the 1 value. Okay, so it starts out 10. This is true. And then it gets decremented. So now it's 9. And this is still true. Okay, all the way until it's 1. Even if I is 1, it's still true. But once it is smaller than 1, once it's less than 1, the opposite, it will pop out of here. And so I must be less than 1 if we got here out of the loop. Alright, so assuming we don't get an infinite loop, I at the very end of this program becomes 0, 1 smaller than it was when we last printed it. Okay, hope you see that. Now, let's compile. Count down. There we go. And so let's go ahead and run this. And hey, we got it working. And this is like, I don't know, maybe it's like a shuttle lifting off. It's like, now we have liftoff. That's fun. Alright, so let's make a new line. And let's do it the for loop way. So the idea with a for loop is you're kind of taking a while loop and shoving things in different places. So the initialization, which originally happened up here before the loop even started, we're going to put that in the loop now. So for int j equals 10, and then the condition stays up here. It's just all separated between semicolons. While j is greater than or equal to 1, keep doing the body, and then also decrement j each time. Okay, that's how those three things work. And oops. There we go, that's better. Now, the only thing we need to worry about in the body now is printing I. That's the one thing we haven't considered yet. And this is like the real work, the thing we care about doing with I that stays in the body. So it's nice that the for loop lets us put all of that extra stuff outside of it. Okay, so this should do the same thing. And then we can also say liftoff. Okay, and remember, j only exists inside this for loop. And that's opposite to what I is doing. It's being declared in main itself, so it's going to stay. Oh, I'm sorry, countdown. That's just muscle memory. And oh man, I have a bug. Isn't that fun? So this happens, and it looks like instead of j, I said I. So I'll replace that. Add a new line. So I was talking about the I that was 0, and I told you it would be 0, and we discovered that. Okay, so now we have two exactly the same loops, just done in different ways, a for loop version and a while loop version. Okay, back we go. Alright, the next thing that I want to show you is continue and break, and these allow you to change the way loops execute. Okay, so this continue allows you to skip a loop. Skip a loop iteration. It jumps you right back to the condition. And then possibly to execute the body again if that condition was true. Condition check, let's say. There we go. And yeah, let's do that first. So I'll make a file called continue and break. Okay, and let's make a loop where we can still count down for int I equals 0, I is less than, or we can count up. I is less than 11, I plus plus. This will count from 0 to 10 in a different way. Cout I. So let's pretend that we hate the number 3, and we don't want to print it out even though we are considering it in our loop. I will be eventually set to 3, and we would print I normally. But if I say, if I is equal to 3, continue, this skips the rest of the loop body of this iteration. And that means it's going to go and check the condition again, because after you're done with the body, and I just told you to skip it, the next thing that you do is always go back to the condition checking, which is in here. That one right there. Okay, so this will skip when I equals 3, and we won't get to this line for that case. So notice that we go 1, 2, 4. Continue skipped that one case where I is 3. Okay, so it just jumped right back to the condition checking, and it did not continue the loop. All right. Well, technically it goes straight to the increment, but it goes back to the top of the loop. Let's say that. Depends on if it's a for or a while loop. And then break gets out of the loop completely. And I'm going to say closest to foreshadow what we're about to do. So break is going to exit the closest loop that you're in, so the innermost one. Okay, so maybe we can have a demo where this program's going to keep continuing, but we stop when the user types Q. We're going to stop our loop. Okay? And let's use a while loop for that one. Let's see. We shall count from, I don't know, 42 onward until the end of time. So while true. Infinite loop. But we're going to have the user stop us. Okay? So let's see here. Let's get a output, a value from the user, enter a character. Q to quit. Okay, that'll be our little prompt. And so we'll get that character, or choice we'll call it. And now that we have it, we can test it. If the choice is equal to Q, we'll break. So this stops the while loop. It goes straight to the end, okay? And starts executing whatever's after the loop. So this is outside of the loop. And so after we call break, we stop the loop, which ends here, and then we just continue the program. And then otherwise, if the user does not break out of this loop, how about we just print out, I don't know, cout j and j++. So we'll just keep printing forever, one by one until the user stops us. Okay? Let me put this up here, I guess. That looks better. Easier to see everything. And now we'll go to continue break. Alright, so we're entering a character, Q to quit. A, B, C, D, E, F, G. So it's going to keep on counting, because it's keeping track of this J. J++, print out J as long as the choice wasn't Q. But the second that the choice is Q, let's go straight to Q, we'll get to this if statement, and the condition will actually be true, which means we'll break out of the loop. We'll leave it. Okay? Hit Q, and immediately we stop the loop, and then the program ends. All right. So that is break and continue for you. Those will be useful. And now let's do something complicated. Now that we are confident in our loop abilities, let's calculate this formula. Let's solve for E, which is that special value that's like in all those compound interest formulas. It's all over nature. Let us calculate the value of E, and it happens to be this fancy summation, which is just this infinite sum. And eventually we want to stop this. Let's go from 0 to maybe the 100th term, and you can see how you might do this in a loop. First, you'll start out your sum just holding this value, then you'll add this one, then you'll add this one, and what changes between each iteration of that loop? What you're taking the factorial of. Okay? So as long as you're making a new term, so your current term, maybe you have an int I, and it holds 0. So your current term that you're about to add will be 1 over I factorial. Okay? And then we'll just add this, which will start out being 1. And we'll just add that into maybe a sum variable. Okay, and let's put that over here. That also starts out being 0, and so we'll put the 1 in there by adding it. Okay, so that is the idea, but I think this is easier to explain in code. So the first thing that I'm going to do, you could look away, is I'm going to write a factorial function, because there's not one in the standard library that I know of, so I'm going to write it. Okay, so I cut away for a second so that I can make this factorial function. Here it is. You don't really have to understand it at the moment, but this takes a factorial is a function that takes an integer that you want the factorial of, and it returns back a double to you. Okay? So we're going to use that. Pretend it's a library function. And so we're going to calculate now this value of e. Okay, so how are we going to do this? We're going to start our loop with a sum variable and an I variable, and we're going to keep on adding into sum the value 1 over factorial of something. Okay? So let's figure this out. We're going to have a double sum variable that starts at 0. We're going to have an int I that starts at 0, because that's where we want to have our first term. The denominator is 0 factorial, so I will keep track of which factorial we're doing. And then that's about all we need outside of the loop, while let's go from 0 to 100, because 1 over 100 factorial is a very small number, so we'll be very close to the answer. We can stop then. Okay, that's the idea. So we're going to compute this current term, which is the one I'm about to add into my sum variable. All right, so I'll compute 1 over the factorial of I. Okay, I hope you see that, and then I'll just add the current term into the sum. Okay, so we'll say sum equals sum plus current term. And so after this, I hope you see how current term is changing. It'll go, and how sum is being manipulated. It's essentially going to do this. Sum equals 0, because that's what it started as, plus whatever the first current term was 1 over factorial of 0, because that's what I will be in the first iteration of the loop. And then after that, in the next iteration of the loop, current term will change because I will be 1 more, I plus plus, I forgot that. And then it'll be 1.0 divided by factorial of 1, because that's what I will be. And then in the next iteration, it'll add on 1.0 over factorial of 2, because I got incremented. That's what the current term is now, 1 over factorial of 2. Add that into my sum, and it'll just keep on going until it goes to 1 over factorial of 100. Okay, so if we print sum, at the very end, sum should be a very good approximation for E now. Isn't that cool? It probably is going to be perfectly precise for what the double prints out to us. Okay, so if anybody knows what E is, let us run our program, and remember what it's doing. It's keeping track of all of these sums, and it's adding them all one at a time into our sum variable. And we noticed that we could use loops because and use our index, because this factorial changes each time. And that's the magic of it. Let's compile and run this. Dun dun dun. Oh, I was testing before this. Alright. Drum roll, please. That looks like E to me. Isn't that cool? So we just used a loop to do something mathematically exciting, and I hope that you enjoyed that. You can actually get away with doing, for 5 decimal places of precision, you can actually get away with doing a much smaller version of I, and I encourage you to play around with that. Alright, so to break up the monotony now, I want to show you a cool way to animate things with loops. And I think I was playing around before, and let's see, did I continue that? No. Alright, so I'm going to go to animation.cpp, that's the file that I'm about to make, and I have populated this with stuff because I was playing around, but I'm going to include that pause function from the karaoke example from lecture 1. And we can use that to animate a cute little star on our screen. So we can have it fall. And animation just means pause in between writing these stars to the terminal screen. Alright, so here's what we can do. We can cout a star, pause for half a second, cout another star, pause for half a second. Continuously do that, and anytime we see repetition, I was playing around, sorry, anytime we see repetition, see how it fell? Isn't that cool? Anytime we see anything like this, we can repeat it inside of a loop. Okay, so here's what we can do. For int I equals 0, I is less than 10, I plus plus. And this is going to be the generic way that I write something that does that iterates through its body 10 times. This loop executes its body 10 times because I goes from 0 to 1 all the way to 9. Okay? And so that's 10 times. And this is the generic way that people like to execute a loop that doesn't really use its I variable a certain number of times. Okay, so that's going to execute 10 times, and it'll do this that we put in here 10 times. And won't that be fun? Now it's falling. Isn't that cute? And then one final thing that I want to show you is with the string library, you can actually make a string in a special way. You can say string s like that, and then you can use parentheses to give it a special starting value. And you can repeat a certain character, a certain string a certain number of times. So I want to repeat this, let's say I plus 1 times. And I plus 1 times, I want to repeat a star. So this is going to change s depending on the loop iteration. And oh man, oh I'm sorry, it has to be a single character. It cannot be a string, I was wrong. There we go. So it's going to repeat this star I plus 1 times and print that out. And I encourage you to take a deep dive into what this is doing, but this is about to be cool. Isn't that fun? And that can continue for forever. You can make your I go to a bigger value like 100. But yeah, that's a nice way to break up the monotony, and I think that is what I want to do. I might have to do some preparation for nested loops, so I will start here and continue in just a second. Alright, I am back. Let us do this thing called nested loops, which is loops within loops. That sounds scary, and it is historically a difficult concept to learn. So pay maybe extra attention to this until you get the hang of it. But the entire idea of it is there's a loop, and inside of that loop is another loop. You can have this go on forever. You can put as many loops as you want inside of other loops. And all that I want you to remember is that this while loop, this outer loop between these braces, has a body that gets executed every time this while loop iterates. Okay, so during each iteration of the outer loop's body, the inner loop must execute completely because it is the body of this loop. That's all that there is. Okay? So that means that this is just like any other piece of syntax, and if we go up here to how a while loop executes, this is its body, and its body happens to be a loop. Okay? So it shouldn't come as too much of a surprise, I hope, that a while loop with a while loop inside of it, each time the outer while loop goes and executes its entire body, that means this entire inner while loop gets executed. And that is very hard to think about, but we're gonna go through this slowly, and let's do it with for loops. Okay, so let's walk very, very slowly through this nested loop. Okay, this is the code, and I'm gonna go and type it now. I'll call it nested4.cpp. All right, so for int I equals 0, I is less than 5, I plus plus. So we know immediately that this loop is going to execute 5 times. For int j equals 0, j is less than 5, j plus plus, inside of the other for loop's body. So we know also that this loop, whenever it gets run, is going to execute its body 5 times. Okay, that's what we know. So executes its body 5 times. The outer one. And the inner one as well. Executes its body 5 times. And inside of the body of the inner loop, we do something with I and j, because I is, well, it's valid to say I anywhere inside, so we're going to use it, and then we'll also say j. We'll see what values those range between. All right, so all right, so I'm going to run this. Take your bets as to what this does, and maybe try right now. Take a second to figure out what you think is going to happen. That will be very helpful for either confirming your beliefs or seeing why they were wrong. All right, so I'm going to run this. And these are the values that I get. All of these. And so we need to talk about why this is happening. And I think the best way to do that is to copy all of this. This is the output. And I'm going to paste that in to where we were, over here. And we're going to see what happens. So the very first thing that got printed out was 0 space 0, then it was 0 space 1, 0 space 2. And let's figure out why that was. Okay? So when this loop starts, so when I'm on this line, I starts out being 0. And you should try this on that C++ tutor website as well. I starts out being 0. Okay? Is I less than 5? Yes, it sure is. So we're going to execute the body of this loop. And so we're going to now go from that line to this line. This is the line we're now working on, which means we're going to execute this entire for loop. We're going to make our j start it at 0. And is j less than 5? Well, it sure is, which means we're going to then move to execute the body of the inner for loop. Okay, I have I equals 0 and j set to 0 as well. So I'm going to see out I and j, which is 0, 0. So now you see why it's there. Okay? And then I'm working on the inner for loop. It has to complete before I'm done with the body, and I can go back to the outer for loop. I hope that makes any sense at all. So that means that j is going to be incremented. Okay? j plus plus, j is now 1. So we'll see out ij again. I didn't change, j did. So we'll print out 0, 1 up there. And then you can see how j is going to become 2. So see out 0, 2. And the same for 3 and 4. Because it's still always less than 5, we're going to continue this loop and complete it. I get 0, 3, 0, 4. Okay, so that is that. Now, we're sitting here. It's like we're working on this in-between line at the moment. We're sitting right here in our code. And, well, that means that this for loop is done, which means that this j goes away. And so I'm going to erase this j. It no longer exists. We completed the loop, and so the j goes away. All right? So now because I'm done with this, I'm done with the body of the outer for loop. Okay? I just completed the body. I completed one iteration of the outer for loop, which involved completing the inner one. Okay? I'm going to say this a million times. Sorry if you get bored of it. But now we're going to come back to the outer for loop. And we're going to increment I. Okay? I is now 1. Is I less than 5? Yes, so that means we're going to execute the entire body of the for loop. So now we're here. So we're going to execute that entire for loop again. We'll make our j start at 0. It's a brand new j, because it's a new loop. Is j less than 5? Yes. Let's print out I space j. What is I now? It's 1, then 0. Okay? Then j gets incremented. We continue the inner loop until it completes. So it'll print 1, 1, 1, 2, 1, 3, 1, 4. And then now we're done. I just realized I can move this. Now we're done with this inner loop. And we can go back to the outer one and increment I. Okay? And j went away because it's been completed. So this is going to continue. It'll go to 2 and then print 2, 1, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. You see that? And then it'll go all the way to 4. And it'll print 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. And once it is here, we're done with this for loop. Oops. We're done with this for loop. And then we come back here, check our condition. I becomes 5 because of the plus plus. And then finally, we're done with the entire loop. Okay? The entire outer loop. So I hope you followed some of that. It's okay because I'm going to show more examples. But what I want you to get away from out of this is that how many times total did we output something? How many times total did this line get executed? And I want you to notice that it's 5 times 5. Okay? So I want you to notice that first. And so that's the first key idea. Nested loops multiply the amount of work that you're doing. Okay? So let's use this to draw a box of stars. All right? So let's make this in code. It might seem complicated, but we're going to do it. We're going to do it with nested loops. Okay? And here's the strategy. We're going to have one loop, the outer loop, that will worry about which line we're on. And so it'll go from here to here to here to here. And on each line, we have to print 4 stars. So that will be the inner loop's job, because that's what we'll repeat 4 times. Worries about printing a line of stars. Okay, so that's that. And let's make this happen. So here's the idea. When I is 0, I will range between 0 and 3. And then our j, the j for each line, will range between 0 and 3, and it'll print out a star each time inside of the inner loop. Okay? That's what we'll do. Stars.cpp. Okay. Are you ready? Let's do this. So for int I equals 0. Now let's use while loops. Why not? int I equals 0 while I is less than 4. We're going to do some stuff and then I++. All right, so this is the outer loop. It'll execute 4 times. I hope you see that, because I goes between 0 and 4. All right. Now we're going to have an inner loop. Int j equals 0, while j is less than 4. We're going to do something, and then j++. Okay? So now we have an outer loop that executes 4 times and an inner loop that executes 4 times. How many stars do we need? We need 4 times 4. Oh, we know where to put that. We'll put that in the inner body, inner loop's body. All right, just like that. So if I run this program, I know that this executes 4 times, this loop, which will cause this entire loop to execute 4 times. And so this body gets executed 4 times 4 times. All right, isn't that nice? This will be called stars.cpp. And so, if you count, I have the correct number of stars. I have 16 stars. But the idea is, after this loop executes once, I've just printed 4 stars. Okay? That's all I ever want on a line. So now, after this loop is done, let's print a new line. So it'll print 4 stars and then a new line. Okay? Okay, let's watch this work. Print 4 stars and then a new line. Do that 4 times. That's the key. 4 stars in a new line, do that 4 times. Yeah, isn't that beautiful? Okay, now, let us, I guess down here, I'll write it. So this is essentially what we're doing. So do 4 times the following. Do 4 times. Print star, and then print new line. Okay? So do 4 times the indented thing. Do 4 times the indented thing. So 4 times I'm printing 4 stars. That's how you can read that at a high level. And then a new line. So 4 stars, and then 1 new line. Do that 4 times, and suddenly you have a box. Okay? It's not as pretty of a box as it is on the slide because these are all kind of squished, so you can change the star to a star and a space to kind of spread them out. That looks better. Okay? So there's secretly a space at the end of these lines before the new line breaks. Okay. We're almost done. Now, let's draw this. Let's draw this box of stars, but not quite. It's got some stuff taken out of the middle. So it's almost this box, so we can use that as a starting point. And let me convert that to a for loop. I equals 0, I is less than 4, I plus 4 into j equals 0, j is less than 4, j plus plus, see out, star space. Honestly, let's keep it the stars. That's easier this time. And then a new line. So this is the for loop equivalent of what we just did. Okay? Without the cool looking spaces. I encourage you to play around with that though and make it work. Maybe I'll print a new line in between. So now, I want to carve out those middle stars here. So now we need to figure out when we're there. When am I about to print this star? And I can make it print a space instead. Okay? So what indices? What are these 4 indices? Is my question. These 4 I and j values. Alright, so this is I 0, 0. Alright, this is I equals 0, j equals 0. This is I equals 0, j equals 1. Things like that. So when we're on this line, I equals 1. That's helpful. And then we're on these columns, j equals 3. Or j equals 2. Oh, I'm so sorry. J equals 1 and j equals 2. And this is the line that we're on when I is equal to 2. So if we just exclude whenever I is 1, j is 1, I is 1, j is 2, I is 2, j is 1, and I is 2, j is 2, I think we're in the clear. Okay? So whenever I is between 1 and 2, and j is also between 1 and 2, print a space instead. Okay? I encourage you to break this down and see why that works. So I'm going to use an if statement now. If I is between 1 and 2, so I is greater than or equal to 1, and it's less than or equal to 2. Okay? I is between 1 and 2, and so is j, so same with j. And j is greater than or equal to 1, and j is less than or equal to 2. If any of that's true, I want to print out a space, and not a new line. Otherwise, I want to keep my star. I meant space and not a star. Okay? So, otherwise print that new line. And I keep saying new line instead of star. Sorry about that. Alright, so what's going to happen now is anytime I is between 1 and 2, and so is j, we're going to carve out our star. We're going to print a space instead of a star. And oh man, is that working? So that's a very complicated example. I encourage you to look at this after this lecture. So that's working. And the second key idea is, notice that back here when we printed out all these combinations, we actually printed every combination between 0, 0 and 4, 4. So all the combinations of 0 through 4 and 0 through 4. We tried every single possibility. Okay? So nested loops, they try all the combinations of values. So with that, we can do this thing called a brute force algorithm, which just tries all the possibilities. If you've heard this before, like password guessing in a brute force manner, that's just trying every single possibility for the password until it hopefully works. And the reason we can get away with this, with trying every single possibility like this, is that our computers are pretty fast. So this is going to work well for these small problems that I might ask you to do. So here is one problem. It's very contrived, but it's fun. So you are a farmer, and or there is a farmer, and she wants to buy 100 animals. And here are the prices. Horses cost $10, pigs cost $3, and rabbits, those are only 50 cents. So sale on rabbits today. So the farmer is going to buy 100 animals, and she has $100 to spend. So those are her two constraints. She's going to come away, she's going to walk away with 100 animals, and she's going to spend only $100. So how many of each animal did the farmer buy? So what we can do is try every possibility. Okay? So let us make 3 variables for number of horses, number of pigs, and number of rabbits. And we'll let all of them range between 0 and 100. All right, so we're going to try all the possibilities of each of these because that's all there is. So every time we're going to pick a number of horses, pick a number of pigs, and pick a number of rabbits and try all the possibilities between 0 and 100 for each of those. So that is a 3-way nested loop. So this is a triply nested loop that we're about to write to try all of these combinations of 3 numbers. All right, I hope you see that. And so let's do this. We're going to do it exactly like this, where it's not I anymore, but it's the number of horses. It's not J anymore, but it's the number of pigs. And so we're just going to try every single possibility of I and J, or number of horses and number of pigs, and also rabbits. And then if we ever meet our constraints, then we know that we solved the problem. Okay? So hopefully that idea is making sense. Please yell at me about this if it's not. So I'm going to edit a file called, I don't know, 100animals.cpp. All right, so here's the idea. So try all combinations of horses, pigs, and rabbits. All animals, the amount of all these animals. The amount of each animal, let's say, can be anywhere between 0 and 100. Any of those values. So here we go. For int horses equals 0, you can have 0 horses possibly and just buy 100 of something else. Horses is less than or equal to 100. Horses plus plus. And I think I said num horses, so let's do that. Num horses. All right. So this will try between 0 and 100 horses, and then inside of that we want to try all the possibilities at the same time of pigs. So let's do the same thing. We'll actually do this. Whee. Darn, it's not very happy at the moment. There. That's what I want. So instead of num horses, I'm going to say num pigs. You can have 0 to 100 pigs. Num pigs plus plus. Alright. Then I'm going to do the same thing, but for... Oh, sorry, num pigs. And now I'm going to do the same thing for rabbits. So now, when I'm inside of this innermost loop's body, num horses is set to a value between 0 and 100, and the same is true for num pigs and num rabbits. And every possibility will be tried between all of those ranges. So inside of here, we're going to try all of the possibilities, okay? Because every possibility will happen once. We're going to enumerate each of them. Okay, we're almost there. So now we just need to solve the problem. We know that the problem has been solved when we've bought 100 animals and the price for each of those animals was $100. All right, so let's keep track of the number of animals that we bought. And that is just how many horses we're considering at the moment, how many pigs we're considering at the moment, and how many rabbits we're considering at the moment. So we have a certain value of those inside of this loop. Maybe it's like, maybe for this particular iteration, num horses is set to 42, num pigs is set to 18, and num rabbits is set to 100. We don't actually want to consider that one because that's over 100 animals. But we're going to try all of those possibilities. So num horses plus num pigs plus num rabbits. All right, we're going. So this will tell us how many animals we're trying to buy at this moment with this current possibility. And now we need to know the price. And that is the number of horses times 10, plus the number of pigs times 3, plus the number of rabbits times 50 cents. All right. So now, if we solve the problem, we only care when num animals bought is equal to 100 and price is also equal to 100. All right. So this is one of those special cases where you can get away with testing for double equality. Don't do this all the time, though. All right, let's do this. So if exactly this, if that is true, we're going to see out the number of horses. And we'll do the same thing for pigs and rabbits. All right, that was a lot of work, but it's going to pay off. So if we ever hit this case, we knew that we bought exactly 100 animals and our price was 100. And we're always going to eventually get there, well, if this problem has a solution, because we're always going to try all of those combinations of horses, pigs, and rabbits. It'll start at 0, 0, 0, then 0, 0, 1, 0, 0, 2, all the way down to 100, 100, 100, if you just follow this same pattern with 3 instead of 2. Okay? So now, if we ever got to this special place, we have found a solution to the problem. Oops. And it looks like there are 2 solutions. Horses equal to 0, pigs equal to 20, rabbits equal to 80, and then horses equal to 5, pigs equal to 1, and rabbits equal to 94. And this happened very quick. It tried 100 times 100 times 100 possibilities in the blink of an eye. And let's confirm this. Let's see here. I'm going to go into Python. So pigs 20 times 3 plus 80 times 50 cents, that should be 100. Yeah, it was. Nice. And then the other possibility, horses 5 times 10 plus 1 times 3 plus 94 rabbits. That's a lot of rabbits times 50 cents. That's also 100. And you can tell pretty easily that these also add to 100. Okay, so those are the 2 solutions to this problem. Okay? All right, so that was a more involved example, and that's good because it's getting us to grow a little bit. So that's where I want to put us right now. So I'm going to have some office hours in a few minutes, so I will come back and graph some circles with you on the terminal. You know what? I have decided that this is plenty for one lecture, and I will see you in the next one.